Off like a Twinkie feeling, playing the villain. Prepare for this rap killing. Biggie Smalls is the illest. Your style is played out like Arnold. And what you talking about, Willis?
Alright, so what we're going to do now is calculate the area. So area enclosed by, and I'll give you a couple functions here. So we have an h of y, which is equal to y squared minus 1, and a g of y, which is equal to y squared minus 1 over 8 y to the 4th, and plus a 1. Okay? So here we see that we have functions of y. So this means that we're going to have to use that second, like the integration along the y-axis. Okay? So we're going to use the right minus left method, the dy method. So here I'm going to say we're using dy. We don't know our interval just yet because we're going to have to find that. And we don't know which one's right or which one's left or anything. We just know we have to integrate along the y-axis, okay? So, what we're going to need is the formula A is equal to our area, C and D of some sort, okay? And then we have an x right minus x left, where x are functions of y, and our dy here. So, what are C and D? How do we find this interval? What we're going to have to do is find where h, so where h of y intersects the other graph, which is our g of y, okay? So to find that intersection, we have to find basically where does h of y equal g of y, at what y value is that? So if we plug in our functions, we have y squared minus 1 on the left, and y squared minus 1 over 8 y to the 4th, plus 1 on the right, okay? So let's say we subtract y squared from both sides, so that those kind of just go away, right? And then if we're going to add this guy, 1 over 8 y to the 4th plus 1 over 8 y to the 4th, and if we add this 1 to the right side, so if we add 1, these would go away, so we ultimately get 1 over 8 y to the 4th is equal to a 2. Okay, so then that means y to the 4th is equal to 16, and y could then be equal to plus or minus 2. Okay, so that in fact gives us where these two graphs intersect. So that means those are the bounds, or the limits of integration. So it'll be negative 2 up to 2, okay? Alright, so now that we have the interval, now we have to figure out which one is the right function and which one is the left function, okay? So what we're going to do is try h of y minus g of y, and we'll see where that takes us. So this is equal to y squared minus 1, that's our h of y, minus g of y, which is y squared minus 1 over 8, y to the 4th plus 1. So when we do that, we get y squared minus y squared, so those ones go away. Right, so those go away, and then we have a negative 1 plus a 1 over 8 y to the 4th minus 1. So this is equal to 1 over 8 y to the 4th minus 2. Okay, so now this is like, oh, okay, it might look positive, I'm not really sure. So what we're going to do is take our interval, and we're going to pick an easy point in between it, or inside of it, okay? And that includes endpoints, so if you wanted to, you could pick negative 2 or 2. What I'm going to do, though, is pick a nice, easy 0, okay? So, at this 0, I'm going to evaluate h of 0 minus g of 0, which is equal to 1 over 8 times 0 to the 4th minus 2. So this is going to end up being a negative 2. So that tells us that this negative sign means that we had it the wrong way around. So we have to swap these, okay? So that means that g of y minus h of y would give us a positive number. So that means that g of y must be the right-hand function, okay? So g is on the right side and h is somewhere on the left side. So g is the right one and h is the left one. Okay, so let's piece together all of this information on the next slide. So we have that our interval is from negative 2 up to 2, and this is our y interval. We're using dy. We know that our right function is our g of y, which is equal to a y squared, and then minus 1 over 8 y to the 4th plus 1. Our left function is the h of y, which is equal to y squared minus 1. So again, if we set up our area function here, we get a is equal to c to d. This is the interval on the y-axis. And then we have x right minus x left, and then our dy. So if we plug in all of our information, we get integral from negative 2 to 2, and our function of y, that is the right one, that's going to be y squared minus 1 over 8 y to the 4th plus 1 minus x left, which is y squared minus 1. and then our dy at the end there. Okay, so let's simplify. So we have a is equal to the integral from -2 up to 2 of, and if we simplify, we get y squared. These ones cancel because that's a negative there. We have a positive 1, positive 1. So we have 2 plus 1s and this term here. Okay, so we're going to get a 2 minus 1 over 8, y to the 4th, and then our dy at the end. Okay, so keep note of this last line here, and we'll continue this on the next slide. So we have a is equal to the integral from -2 up to 2 of 2 minus 1 over 8, y to the 4th, of dy, with a dy at the end. So now we're just going to integrate, so we get 2y, and then minus 1 over 8, and we have y, not next, y to the 5th, and then 1 over 5. We're going to add that factor in there, okay? And this is evaluated from -2 up to 2. So if we continue simplifying, we get a is equal to 2y minus 1 over 40, y to the 5th, evaluated from y equals -2 up to y equals a positive 2, okay? So now we're just going to plug these guys in and see what we get. So a is equal to, our area is equal to 2 times 2 minus 1 over 40 times 2 to the 5th power, okay? So that's when we plugged in a 2, a positive 2 that is, and then we're going to subtract when we plug in a -2. So 2 times -2 minus 1 over 40 times -2 to the 5th power. Okay, I think I have enough parentheses there. Alright, so now we're going to get a is equal to 4, and then minus 2 to the 5th is a 32, so 32 over 40 minus, and now we have a -4, and then this is going to be a positive 32 over 40 as well. So we're basically going to double all of these values. So we get that this is equal to, so this becomes positive, and that becomes a negative right here. So this is going to be 8 minus a 64 over 40. Okay, and we'll continue. We'll finish this up on the last slide. So this is going to be a is equal to, so our area is equal to 8 minus 64 over 40, which is then equal to 8 minus 8 over 5 if we divide by 8 on both of those. So a is equal to 40 over 5 with a common denominator there. So our final answer is going to be a 32 over 5. A positive 32 over 5. Okay? So, just as a review, because that was quite a lengthy question, our last problem covered integration along the y-axis. Sorry, so integration along the y-axis there. Okay, and then how to find. Remember, we found the intersection. So how to find the intersection between two graphs. So between two graphs, we basically just set them equal to each other, right? Their formulas, the functions there, and then thus the limits of integration, right? We found that -2 up to 2, limits of integration, and the last thing we did was how to determine which one is the right function and which one's the left function, right and left functions, okay? And pretty much doing that, determining or identifying the right and left functions, that's kind of similar to the process of how to determine top and bottom functions, right? When we're integrating along the x-axis. Okay? So that's pretty much it. That wraps up our concepts video on the area between two curves. I hope that helps, and good luck on your homework.
In the ass whipping, hey, I'll be kicking. You son, you doing all the yapping, acting as if it can't happen. Your frontin' got me mad enough to touch something. You want from Shallon?